Hey everyone, it's your math teacher Mr. Boyden, back at it again today. And today we're taking the things from the last video in our last lesson where we learned side, angle, side, 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 angle, side, angle, and angle, angle, side. And today we're going to use those four congruence theorems to write proofs. Okay, so today is just going to be a whole bunch of examples. There'll be some explanations mixed in, but we're just going to run through some examples. Our first one's up here on the board. If you're watching this right now and you don't have notes, you haven't been through the lesson yet, then I want you to pause the video, write down what you see, and then you're going to take really, really good notes. If all you do is watch it, the stuff probably won't stick. The whole point of this is to augment and or fill in your notes if you miss class or something like that. So if you need to pause the video right now so you can get that down, then do so, okay? And don't hit play until you're ready. Okay, let's get started. Okay, the first thing that you need to do if you want to write a proof is we're going to start, and in this class we're going to start out by putting down a table. And that table is going to have two things in it. It's going to be to separate out our statements and our reasons for why we know those statements are true. Okay, and so as far as statements, we're trying to create a list of things. Maybe it's sides, 3 sides for side, angle, side. Maybe it's 2 sides and an angle for side, angle, side. We're taking information about the scenario we're given and we're writing down statements that we know are true. So one that I know is true is right here in the given. Anything that's given is always going to be true. That's what it means to be given, that true information was given to us. And so I'm going to write that first, and I'm going to write it exactly as it's written. Side AX is congruent to side AY. And the reason that we knew that? Because it was given information. Okay, that's a perfectly good reason. There's my first statement. Now, these statements have to be symbolic. For this part of the class, we're not writing out sentences, and so sometimes that frustrates people. But we're trying to have something symbolic that's mathematical. That was all symbols. I didn't write any words at all. But here's where that gets a little bit tricky. Right here, we're told that M is the midpoint. And I can't write that in here. Because M is the midpoint, I'm now writing a sentence. And we can only write symbols. So what we have to do is think about, okay, what are they really trying to tell us? Because they're being a little bit cryptic. So what I'm going to do is I'm going to look up here. M is the midpoint of XY. This is the middle of this segment. And so if M is the middle, then which side, XM or MY, which side is longer? Well, you should say neither of them. It's in the middle. If M is in the middle, the two sides are equal. And that's exactly what they're trying to tell us. They're trying to tell us this length and that length are the same. And that's what we can write down in our table. So I'm going to try that. XM is congruent to MY. How did we know that? Because we were told that M is the midpoint. So I'm going to write that down. M is midpoint of XY. So in our reasons column, we're totally allowed to write sentences. You could write a paragraph if you wanted to. You can explain as much as you want to. But on the left, we are looking for symbolic statements. Now, one thing I hope you notice is that I marked these two segments. Anytime you write a statement, we want something on the picture to match that. And so actually, I need to go back to statement 1. AX is congruent to AY. AX is congruent to AY. And I need 2 tick marks, because if I say there's only one, then I'm claiming it's the same as these 2 segments down here. And we don't have any information to know that that's true. So now that I've got those, the next thing I'm going to ask myself, it's kind of like asking, are we there yet? Are we done yet? Let's see. I've got a statement about side congruence here. I'll put a little S. And a statement about side congruence here, and that's a little S. And the way we know when we're done is when we have one of these 4 things. Side, angle, side, 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 angle, and angle, angle, side. Now notice, all of those have 3 letters in them. And we only have 2 statements so far. So no, we're not done yet. We need at least one more statement. So we've used all of our given information, which means now it's time for us to stop and think, is there some other information I can come up with on this picture? And so we're going to look at it, and let's see what we can figure out. Now, the thing we learned in the last lesson was when 2 triangles overlap perfectly, or the analogy we had in class is if 2 people stand back to back, they line up perfectly. What we call that is the reflexive property. And so I've added these lists of reasons. That lines up with these possible reasons. Midpoint was a reason, given was a reason. Reflexive is going to be our next reason. And think about that. See how there's 2 triangles? They're lined up perfectly back to back, and they're the same height. That indicates that there's a reflexive property. And so I'm going to mark that side right down the middle, and now we're going to write that down. So that side goes from A to M. That's the left triangle. On the right triangle, it's also A to M. And that can be really, really confusing for people. Let me write down that it's reflexive, and then I'll explain it. here's the deal. In our first statement, we talked about AX. AX was on the left triangle, and AY. AY was on the right triangle. Left, right. In our second statement, XM was on the left triangle, and Y was on the right triangle. Each of these statements compare one triangle to the other. And so what we write here has to compare the two triangles. So technically speaking, that's saying that AM is in the left triangle and AM is in the right triangle, and it's the same in both of those. So there we go. Now folks, take a look at how this is written. I've got 1, 2, 3 marks, 1, 2, 3 marks, so that falls into side, side, side. I've got 3 side congruence statements. And so I'm going to end my proof by saying side, 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 and the thing we write over here on the left side is always the prove statement. Always. And so let's write that in. Triangle AMX is congruent to triangle AMY. Oh, sorry, I ran out of the space a little bit. Triangle AMY. Okay, and so that part's really easy. Don't get creative. You're going to write down exactly what you were told to do. This now is a complete proof. It's a logical, step-by-step progression that explains what we know and why we know it. And these 3 things up here lead us, side, 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 to our conclusion. Okay, this one's done. That's an example of how to write a proof. Let's try a few more. Okay, here's one that's involving a bridge. It's a little bit hard to see the picture in the video, I'm sure. So I'm going to try to draw it in red, and maybe that'll show up a little better. For some reason the yellow doesn't show up that well. Maybe the red doesn't show up that well either. You know, maybe I'll actually just redraw the picture so you can see it a little more clearly up against the white background. And so based on the last example we did, I'd like you to try to predict right now what the first thing I'm going to do is. And see if you can predict what we're going to do after that. So the more you pause the video and try to make those predictions and then get feedback based on what I do next, the more you're going to learn and connect the dots, and you'll sort of build up that mental muscle that we need to get. Okay, first thing I'm going to do on this one, well, of course I'm going to jot down my table. And this time I'm going to abbreviate it S and R for statements and reasons. And then try to predict what the first thing I'm going to write down is. How am I going to decide what needs to go in this table? Because for some reason starting is the hardest for some people. Okay, and so all I'm going to do, I'm going to look up here at the given information and I'm going to write it down exactly as it was given to me. So AB is congruent to CB. Given. Let's see, did they mark that on the picture? AB, CB, they each have 1 tick mark. Okay, so that was already given on the picture. Let's write down our second statement, and it's right there. AD congruent to CD. Given. Alright, that wasn't too hard, was it? Okay, all we've done is copy stuff down so far. We're just like a Xerox machine. We're copying stuff in. We haven't even done any thinking yet, but now is when we have to do a little bit of thinking. Okay, and so we've had 3 new reasons so far. We've had given, we've exhausted that one. We had midpoint. Do we have any information about midpoints? Well, no, we're going to look in the given. We don't see the word midpoint there, and there's nothing labeled. It's not going to be a midpoint. So let's see. Do you see anything reflexive? Are these 2 shapes back to back? Yeah, they are. And so we have that third side in here in the middle, BD, which is reflexive. So we say BD is congruent to BD. How do we know? Because of the reflexive property of congruence, which I'm just going to write reflexive. Okay, I'm going to pause, ask, are we there yet? And let's see. We have a side statement, and a side statement, side, side, side. Yeah, we're there. And if you're not sure, look at the picture. This relates back to assignment 4-2. Okay, we had 1 side marked, 2 sides marked, 3 side marked, 1, 2, 3. Yeah, this is side, side, side. So that's going to be my reason. Do you remember what I'm going to write here on the left side? I need the prove statement. So I don't have to come up with something new. I'm copying in what they said. So triangle ABD congruent to triangle CBD. Okay, and so people get a little stressed out when they learn proofs, but here's what I want you to remember. This whole line, we didn't come up with. We just copied it down. This whole line, we didn't come up with. It all came from right there. Okay? What about this last line? We didn't make that up. It came in the question. So the only things, we only filled in 3 of these blanks. We came up with one new fact, we wrote down its reason, and we wrote down the reason that we know that's true, side, side, side. We only had to come up with 3 things. So guys, you definitely can get the givens. And you definitely can get that. So all it is that we have to learn is how to fill in these other little missing pieces. And so if you keep that in mind, maybe this will be a little bit less overwhelming. Okay? Let's get some more examples and keep getting a little more fluency with this. Okay, let's try this one. Now again, you may need to pause the video. You probably want to try to write this down. See if I can make it a little bigger so it's easier to see. Just a little bit bigger. Okay, and so let's start working on it. If you need to pause because it's going too fast, make sure you pause the video, and then when you're ready, hit play. Okay, I'm going to get my chart down. Oops, looks like I'm still on the highlighter. Okay, I'm going to get my chart down. Statements, reasons. Let's start filling it in. At this point, you should recognize we're going to start by writing down the given. Triangle RSG congruent to triangle RSH. I think I'm going to try again. My penmanship is not looking so good, so I want my notes to look really good. I'm going to try again. Okay, triangle RSG is congruent to angle RSH. A little bit better that time. That was given information. Pause. You need to label the picture. Guys, in class when we taught this, some of you failed to label the picture, and then you can't mentally connect what we did to our previous lesson. Our previous lesson was totally visual. And so yes, we have writing now, but we need to make the connections between the visual and the writing, otherwise we're going to be confused. So angle RSG. RSG, that's right here. One mark. RSH. RSH. Just trace it. R to S to H. There's that other angle there. Now I've got it marked. Okay, let's keep going. I've got segment SG is congruent to segment SH. Mark the picture. 2 pieces of information. Remember, we always need at least 3. Sometimes more, but at least 3, so we're not done yet. 1, 2, we're going to fill in 3. Make sure you get your given in there. And we haven't done anything new yet. All we've done is copy down the given, and we wrote on the picture. So now we have to look again. Can you tell what our next move is going to be? Anytime you have shapes back to back, that's called what again? That's the reflexive property of congruence, and here they are. They're back to back. And so we have R to S. I'm going to fill that in. RS is congruent to segment R. It's congruent to segment RS. What was the reason? It's not given. That was the reflexive property. Anytime they're back to back. Anytime they're back to back, that's the reflexive property. Okay? And let's see what we have. Look at the picture. We now have to decide, is it side, 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 angle, excuse me, capital, angle, side, angle, or angle, angle, side. There's a couple of ways we can tell, okay? One thing that I like to do is label these up. That was about angles, and then we have side, and then we have side. And sometimes people get confused when they see this, because in the last video I made a really big deal about the order mattering. And if you notice the way this is written, it just happened to come out this way. We have a little bit of a bad word on the screen here, okay? That just happens sometimes. These statements, if I had flipped these two, I mean, these aren't in order for a reason. That's just how the book happened to write them. And so I'm not worried about the order of these, but I can look up here and say, well, I only know about 2 sides. Well, side, side, side requires 3, so that's out. Angle, angle, side requires 2 angles. I can't find any more angles. That's out. Angle, side, angle requires 2 angles. That's out. Side, angle, side is what's left over. And so now I'm going to look and say, well, is it true that if I trace these sides, the angle's in the middle? Let's try it. Okay, so I trace this side right here, trace this side right here, and yeah, the angle connects those two. Trace this side that's labeled, trace that side that's labeled, and yes, the angle connects them. So yes, this is going to end with side, angle, side. Okay, so my final statement, remember, I'm not making it up. It was given to me. It's right over here. So triangle RSG is congruent to triangle RS. Oh, I've done it again. I ran out of space. All right, I get a redo. I get 2 redos. Triangle RSG is congruent to triangle RSH. Okay, and now we're done. Now, some people will ask, well, but wait, Mr. Boyden, what's the answer? Like, is the answer 6, or is the answer 12, or 2x plus 5? Here's the thing. the whole thing is the answer. Okay? Because what we're doing is we're thoroughly proving something to be true. And so if any one of these steps is missing, the whole thing falls apart. It's like a house of cards. So some people say, well, wait, the answer is side angle side. It's not. That's just the last thing we wrote. It's like saying the last word of your essay is the answer to the essay. You don't answer an essay, you write an essay. And so we're writing out a proof. This is replacing a whole paragraph of information. Just think, we could write this out. We could say, we know that angle RSG is congruent to RSH because that information was given to us. And we also know segment SG is congruent to segment SH because that information was given to us. And because we understand the reflexive properties, when things are back to back, we can look at this picture and realize RS is congruent to RS, and it's in both triangles. And because of that, and the way we labeled the picture, we know that we have a side angle side situation, which proves that triangle RSG is congruent to triangle RSH. Now that would take a while to write out. That's a lot of words. So rather than writing that out, we're saying the exact same stuff, but in the smallest number of symbols possible. Okay, math is all about efficiency, so that's why we're doing that. Okay, a couple more examples. Okay, let's try this one. Make it as big as possible so you can see it. Remember, pause the video, write it down. You're taking notes as we go, because you need really good notes so you have something to refer back to. And if you have questions, because if you watch the video, bring them into class. Like if you say, I didn't understand this one part. Bring it in, circle in your notes what didn't make sense to you, and I'll be totally happy to explain it to you. Okay, let's start with our given. Oops, gotta switch back to pen. Statements, reasons. Now the first thing I notice when I look at the given information, when I go to write that down, it's not symbolic. And remember, I said these statements, they have to only be symbols. You can't write sentences. However, that's a sentence. It's got words in it. You can't write words over here. So what we have to do is interpret that information. It's very similar to when we were told there was a midpoint. We didn't write out that there was a midpoint. Midpoint was a reason. And so when I see this word bisect is telling me that's a reason why something is true. It's not the fact itself. We're going to use that because what we care about is congruence, and I don't see a congruence symbol in the given. So let's think about what that does. AE, that's right here, and BD bisect each other. Okay, bisect. What does bisect mean? Bi means two. Sect translates roughly to cut, so it cuts it in two. The one thing that we talked about earlier in the year, but it's been a while, bisect means it gets cut into two equal pieces, or two congruent segments. So what I can learn from that then, this one cuts that one in half. But AE also cuts BD in half. And so I can say, well, wait a minute. If BD got cut exactly in half, then this is the same as that. And if AE got cut in half, then this is exactly the same as that. Because it got cut into two equal halves. Now that's a lot of information out of one sentence. Let's try to write it in the table and see what it looks like. Okay, we'll color code in red. This is DC and that's BC. So I'm going to say DC congruent to BC. Make them segments. Why? Because DB is bisected. So segment DB is bisected. Okay, let's go to the other one. AC congruent to EC. And how do we know that? Because the whole thing got chopped in half. That's why we have two equal pieces. So I'm going to say AE is bisected. Now, in your notes, I want you to keep a list of possible reasons. The reason that could be helpful, the reasons could be helpful, is if you have all of this, that almost serves like a multiple choice question. You know there's certain answers that often pop up in here, then all you have to do is interpret the visual and the words and see which one makes the most sense. So I'm going to add that on here, that bisector is a reason. And I'm going to add to that cut in half, something getting cut in half. Okay? So now I have two statements, both of them are outsides, and I need more information. I've used up the given, and so now we just have to look at the picture, and we have to see what else we can figure out. And so the thing that jumps out is actually an angle, and this is the first time this has come up. If you notice angle ACB right here, and angle ECD, which one's bigger? Well, they're the same. Do you remember why? What it's called? When two lines cross, the angles that are opposite from each other? We had that on our last test, actually. That's vertical angles. And so if those are the same, I'm just going to write that down. And I have a good reason. If you have a really good mathy name for it, that counts as a reason. Because I know what they are. They're vertical angles. Vertical angles are always congruent. Okay, here we go. What are the angles? ACB is congruent to angle ECD. How do I know? Because they are vertical angles. Now we look at the picture. This one is labeled as side, angle, side. The two triangles have identical markings, and so I know this ends with side, angle, side. And what am I supposed to write over here? The proof statement. So here we go. Triangle, ACB, congruent to triangle, ECD. Okay, we had our starting point, our ending point. We have three statements here that match perfectly with that. That's how we know we've written a valid proof. Okay, this one is written out a little bit differently, and we have to be a little bit strategic about how we pair these up, because look, that's one big sort of run-on math sentence. Okay, WZ is congruent to ZS, is congruent to SZ, or SD is congruent to DW. They're all the same. Okay, now, if that gets confusing, that's no different than me saying 2 plus 3 equals 5 equals 4 plus 1 equals 3 plus 2. Okay, those all say the same thing. Those are all different ways of writing out 5. They're all equal. That's all that's saying. All those four side lengths are equal. Okay, so just like any other time, make a little table, statements, reasons. And in this one, we've already got a bunch of stuff lined up. And so I'm going to start with what I see. WZ is congruent to pause. WZ is right here. We have to try to figure out where is that same shape on the other triangle. And in this one, it's not really clear. If you flip this top triangle down, this side lands there. But if you rotate that triangle, it lands right there. So it's up to interpretation. However, we have to be consistent. I'll show you what that means. So for this one, let's think about it as this triangle getting flipped downward, and so it lands on ZS. And that's given. Okay, statement 2. Now I'm going to come over here to WD, and if I pick WD, it matters what two letters I pick next. Because if I decided this shape got flipped downward, where does WD land? It lands right here on SD. And that information is also given. And if you're not sure, WD, DW, it's right there. SD, SD, that's that exact statement. And this exact statement is right here. Okay, so they match. Okay, I've got those two statements. I would like you to try to figure out what the third one is going to be. Now, it is one of these four, and y'all, it pretty much always will be, okay? I mean, or we're going to add to that list as we keep going. We're going to learn more and more different reasons, but it's one of those things. Do you know which one it is? Is something getting cut in half? Is there a midpoint? Is something back to back? These are back to back. They're sort of side to side, but they're lined up perfectly on an edge. So this is a reflexive property. And where is that at? It's right down the middle. So I'm going to say ZD congruent to ZD. The reason is reflexive. I have side, side, side. All three side congruent statements. And so this is a side, side, side proof. That's how it ends. And we're going to write down our proof statement. Triangle WZD congruent to triangle SDZ. And it's done. Okay. Oops. Okay, make sure you get the picture down. We're going to dive right in. Okay, so in the given, there's two lines, there's two statements. Only one of them is going to be written in this table. Can you tell which one it is? It's the second one. Second one is symbolic. The first one has words in it. We can't write that down. But I can write GJ is congruent to GM. I want to double check, make sure it's labeled on the picture. GJ labeled. GM, it was already labeled. Okay, so I don't have to rewrite that. It was already labeled. That's good. That information is given. Now, the first statement has the word bisects in it. I can't write words over here, but I can write words on the right side. So I'm going to write angle JGM is bisected. Now, before we had a segment that was getting bisected, and that created two equal parts. If you have an angle that's bisected, now you have two equal angles. Think about it like you've got a slice of pizza. But there's two people, so you bisect the slice of pizza. And whatever this angle was, now you have two smaller slices. But if you're fair, you want to have those two slices be equal. We're doing that exact same thing here. That's all bisect means. Okay? And so what we get then, if you bisect a slice of pizza, you get two slices of pizza. If you bisect an angle, you get two angles. Okay, whatever you bisect, you're getting two of those now. Okay, so let's fill that in. Let's figure out what that angle is. Now, angle JGM is what got bisected, and that means it's getting cut in half, so here's your two equal pieces, from here to there, and from here to there, going back to that pizza analogy. Okay, so JGK is one of them. Angle JGK must be the same as the bottom one, MGK. Angle MGK. Statement 1, statement 2. Looks like we have one statement about sides, we have one statement about angles. We need a third statement. And we've exhausted the given, so it's not there. This is where we have to think. We have to look at the picture and see if we can come up with a new piece of information. And so again, we're looking at these reasons over here. You should have these written down in your notes. And do we see a midpoint, reflexive, or bisector? These are back to back, so I hope you're seeing how frequently we end up with things that are reflexive. That's really common, especially as we're just starting to learn this. We're going to see a lot of proofs that have the reflexive property in them. So I'm going to write down reflexive. I'd like you to try to write down what you think needs to be written on the left. We've seen quite a few of them now. Now, if you need to pause the video, look back in your notes so you can try to make that prediction. I want to see if you can figure out what this missing piece is over here based on what you see in the picture. Okay? And that's going to help you start to get this a little more if you start to do it independently. Okay? We had these angles labeled. We just labeled. We have this reflexive side. And so what that needs to be, I'll fill it in now, that needs to be GK congruent to GK. So now, looking at the picture, we have a side, we have a side, we have an angle. Is the angle between the two sides? Let's check. Trace the side, trace the side. Did both hit the angle? The angle is down here. Yes, it did. So that's going to be side, angle, side. The angle is in between the two sides. And I'm going to write down the proof statement. All done. That's going to conclude today's practice. Hopefully that's enough to get you trying it on your own. If you have questions, bring them to class so we can address those, or come see me in seminar time and get a little extra help. Until next time, I'll see you then, and have fun. Bye!